want to try and tell a story about the file cutting trades of Sheffield. Files have been made for thousands of years. They're certainly mentioned in the Bible, and in the last 40 or 50 years they've disappeared virtually from the face of the earth. We don't use them anymore, and because of that I thought it was quite useful to show something about what files are for and how they were made in Sheffield. This is the hand making process that used to be done up to around 1850 until machines were invented, but the last hand files were cut in Sheffield up to about 1960 for specials, just making one or two for specific orders. This is what we call a file cutter stock. This is a log of oak, and this would have been maybe in the kitchen of a small house in which the housewife was a file cutter, and while she's cooking the dinner and watching the children play in the yard, she's also cutting files. This will be in front of the window. Here we have a protrusion off the side of this. It's actually part of the log, and your foot goes on there. That is to raise the position of your knee to this particular level. I'll tell you later about it. Sunk into the oak is an iron anvil that is faced with steel. It is bedded on fresh horse manure, simply because the underside of this anvil or the top face of the hole is never actually flat, and it would rock, as we call it. It would wobble. In order to ensure a mating of the two that's actually solid, they used to put fresh horse manure in, and it would bed itself down. So that's put that into that. The two straps on, or this strap on here, which does a loop and back again, is to put my right foot in order to clamp the file down so it doesn't move. But before we do that, what they did was to put a lead bed on. This isn't a very good representation, but at least it keeps in place while I'm doing it. So this foot comes up here like that. This foot's clamping this down, and we next have to come to the hammer and chisel that's going to do the work. And these files were all what we call hand cut by hammer and chisel. This is a file blank, which is high carbon steel that's been softened. We call it annealing. It's softened, and then it's ground, and then it goes through a process of making this surface exactly flat called stripping, and we will tell you about that later. This is called a heft pipe. It's a handle, and I can hold it there, and I can control when this doesn't move back in use when I'm cutting. I can hold it there and push it forward or keep it. So that's that. This is a file cutting chisel. These are quite interesting things. That's a bit larger one for you to see. And that chisel is a triangular shape, and its dimensions, the width and height, are exceedingly interesting, because with the chisel and the hammer, there's the hammer, these two tools are in control of the person who's cutting the file cutter. Anybody who uses these, they might think they're in control, but they're not. These two tools are, by their very shapes, how the weights are distributed. So to use it, what we're going to do is to put the chisel on the face of the file blank and hold it. And we hold it with two fingers at the back, my thumb at the front, and you'll see there's not much difference between the top of that finger and the top of that chisel. If anything goes wrong, I shall be dropping it quick. Before we start, what we have to do is to make sure these faces are clean. paper please. And to do that, we get the face of that and rub it slightly, like that, to take off any grease that's gone on it, and also with the hammer face, like that. Incidentally, this is an old shoe of mine, which is in effect a holster. So when I've done with it, I drop the hammer there, and it's there, so I can pick it up very quickly. Time and motion hadn't been invented then, but by God, they were in front of everybody else how to do things. So we start at the point of the file, and having the little finger, we should actually have an oil patch and lightly oil the file, but because it's a bit oily, I'm going to miss that part out. We'll see on some hammers, by the way, that one in particular, you can see where the wear of the user's thumb has worn it away. And we have several hammers like that to show how much wear these things have had. So here we start. I'm bouncing, you see. Ooh, I nearly did it. That's the effect. Very poorly done, because they're one-sided and they shouldn't be, and also they're too widely spaced. I know that, but this job is a case of practice makes perfect, and I haven't practiced, and it's by no means perfect. I know that. Oh, stand that there. See if I can do a bit better this time. You've got to feel it, and that's half the job, sort of thing. I was just thinking, by God, you're doing good, Hawley, and then all of a sudden I missed strike. That's better. Now then, I think I've got it. I should have my elbow tucked in so it don't move, and I didn't. So I'm learning all the time because I forget. These are affecting me now, these things here. I'll do stand the other side. If you want to do some on here?
Yeah.
Not very good really, but it goes through the motions, and it gives people the idea of how it was done. It is a repetitive job. It is practice makes perfect, and as such, obviously you speed up, very much so, and the ability to know when your chisel is in the right order, and so is the hammer, and everything comes together the right size of hammer and chisel for the work in hand, makes it much easier. So it's really, that's the sort of thing that you learn as you learn the trade. Because I rarely do it, I do not wish to make excuses, but that's why it seems that I am not doing as well as I might on it. This is the introduction to the manufacturing by hand of engineers' files, or indeed files for sharpening saws. Nowadays, in the 21st century, files are almost unknown, but for hundreds of years, a file was an essential tool for sharpening items made of steel, for removing metal that wasn't required, and for making parts that didn't fit together by taking off small amounts of metal. the trade that used them were known as fitters. It's now a word that's gone out of use because of the increase in precision machining and the movement of technology generally to things actually being manufactured so they fit without any adjustment, means that the file has become obsolete. But as I say, for hundreds of years they were an essential part of any metalworker's toolkit. This is what a file looks like typically. There were many sizes, of which this is an average size. They range from, I'm going to use pre-metric sizes, from about 3 inches long up to about 36 inches long, and any size in between. Most files were, say, from 4 inches long up to about 12 inches long. This is 10 inches for this one. Many different shapes, the files have teeth on them. It's a bar of steel that's hardened and they have teeth on, and in use you put the file on the work and you push it in such a manner, and what it does is to remove the surface of the metal underneath, because the hardened teeth bite into that metal and remove it, and you could get to remarkable accuracies if you were good enough to use a file, and very, very few people could use a file properly. However, what we're going to talk about now is the actual manufacture by hand of a file, including all these seemingly thousands of teeth that were cut into the surface of the metal. The file started off being used to be made by having bars of steel rolled in a rolling mill, and they might be 30-foot long bars that were actually cropped up into shorter lengths, something like this part here. So this section of steel will be in a very long length. It will be cut up into short bars, put into a fire, a furnace if you wish. One end will be pushed in like that, and then it will be drawn out, and a man with a hammer and an anvil would forge that on it. That's known as a tank, and that's a handle fits onto that, so that when you're actually using the file like that, you've got something to hold that's comfortable, etc. And the means of attaching the handle to the file is this tank. So that was more or less the first thing to be done, drawing out the tank. It might also, not in this particular one, but you might also draw down the end of the file slightly, or whatever shape was needed. This is a very simple shape file for the purposes of description. After that, after the forging, these blanks, as they were called, were put into a furnace and what was known as annealed, softened, so that the subsequent processes could be done. And after they were softened, they then went to a grinder who ground the surfaces on them on all sides, like that. This is a different section file that I'm going to show you. I've got one here which might well illustrate a smaller one of the same sort. We call this a hand file due to its shape, but that's after it's been ground, like that, on all four sides. Now, in many cases, the grinding wasn't actually smooth enough or accurate enough for the finished file, and in days when this was done by hand, and machine file cutting came in around 1860, the last hand cutter finished 100 years later, who would only be doing specials, not run-of-the-mill files that were made in thousands upon thousands, in enormous quantities. But they, at one time, all used to do this process. And the problem is, how do you make that file? This itself is filed, but this surface is filed at the moment. with the finished file. So that has to be filed absolutely dead flat, and you've got to hold it. The problem is in when one is filing in use, you tend to roll the file like that. It's a natural action of the arm to roll it ever so slightly. That's exaggerated. So you're getting the round surface, which is not what you want. Some years ago, I went to a village called Ecclesfield, north of Sheffield, and talked to an old lady who was in her 80s, and in conversation she said, as a girl, after leaving school, before she went home, she went to her uncle's, who was a hand file cutter in the village of Ecclesfield, and she stripped files. Now this is a 10-year-old girl who was doing this highly specialised job of making that absolutely flat in that plane there, absolutely flat, crossways, on each of all three sides. It's done in a few seconds, absolutely perfectly. So how was this to be? And she left me, she didn't say that, but all she said was she stripped files. And sometime previously I'd got some old bits of wood that were acquired with some other things, and I had no idea what these were. And over time I was thinking about this, and I've got one of these pieces of wood, and there it is, and I looked at it and I picked a file up and I thought, right, if we put that like that there and we put it that way on, we pick our file up like that and we do that to it, which is known as draw filing, even though we might be rocking the file one way or another due to the action of our arms, the file itself rocks with the file blank rocks with the file that's been filing it, and by that means you get an exactly perfectly flat surface. So very simple, not easy to describe or understand, but that very simple method, by doing that, which seems so easy once it's pointed out, but so by asking people before you show them it, it seems to be something that you cannot possibly do. But there it is, so very, very simply. So files of this sort, what we call 3 square files, triangular files most people would call them, but they're always known in the Sheffield trade as 3 square files, which were many were used for shortening saw teeth. So wood saws would be used for that, to sharpen these with wood saws. All had the file blank produced in that way, which in really is a very, very interesting aspect. After that, after the files have been stripped, they then go to the file cutter. So remove those, and we'll pick up a file blank like that, and we have an oil pot. You have to take my word. Usually it has a piece of leather bound up, but for this exercise we just have to wipe it like that to lubricate the surface. They make sure that the file cutting chisel and all, oops daisy, we'll use this one. This is a file cutting chisel, a peculiar shape, the triangular. There is the cutting edge there. This is where the hammer strikes, and this has to be sharpened. So they get this is a piece of slate, and they get that, should have a little bit of oil on it, to keep the edge sharp of the chisel. Put that down, put that away. And the file cutting hammer. This is the most unusual sort of hammer you're ever likely to see. You can see that the face, this piece here, is almost at 45 degrees to the handle, and a very peculiar shaped head. It's a small face, This particular one is made of wrought iron. All that material there is wrought iron, and right at the very end, the last eighth of an inch, that difference in colour you can see is because that is a crucible cast steel face that's been welded onto the iron, and that can be hardened. This gives the weight, and this very expensive metal, crucible cast steel, that little bit can be hardened, and that takes the wear that is going to be imparted to it by striking the head of that. So that's the hammer. There are other things to talk about, but we'll come to them perhaps later on. This is the file cutting stock. It's a piece of tree trunk, in a sense specially selected, in that it has a step on it here. The step is a very important feature. A rectangular hole is cut into the top of this, and an iron block is put in. That is wedged in place round four sides so that it doesn't come out. But a most interesting feature is that between the bottom of this block and the wood is put a very special material, which is fresh horse manure, which people might laugh at, but I assure you it's a very important thing. Simply because the bottom of the hole here is it's nearly flat, but not quite so, and the bottom of the anvil is also uneven slightly. If you put the horse manure in, which is fresh to a certain depth, when you drop that in on top of the horse manure and tap it down, you find that it beds itself. Now that's very important. Some of these stocks, as they were called, this wooden part here, this is a wooden one of course, some were made of stone. Exactly the same principle with a square hole. And stone is very intractable. And the last thing you want is that either on wood or stone is for this anvil to move within the stock. So the horse manure actually was the interface between the wood or stone and the iron and made it perfectly secure. It also ensured that it had a slight little bit of what we call give in it, a little bit of movement, so it wasn't absolutely solid. And I think that was quite important in the days when people were all day long using this hammer, day after day after day, month in, year out, thousands and thousands of times. And one of the problems they could get was they could, what we call today, repetitive strain injury, tennis elbow. In grinders language, you could have an illness called dropped wrist. One of the problems was they had to have a piece of lead like this, so that when you've cut one side of the file with teeth and you've turned the file over to cut the other side, the teeth that's already cut on the underside, so they don't get blunted by contact with the iron face of the anvil, they have this lead. But whilst the file cutter's holding the chisel, is actually touching the lead, his fingers come in contact with it. So he's got his sandwiches at the side, takes a bite, puts it back, keeps cutting while he's eating his dinner, and is ingesting the lead from there. Also, the teeth that's underneath here are gradually chewing away at this lead and causing little bits of dust to come up in the air, and he's breathing that in because he's over this lot, as you can see. So they had awful problems, and this caused this illness called drop wrist, and they went grey, and they lost the pallor, they lost the appetite, and it was a serious illness in Sheffield at that time. So we've got the stock, we've got the stiddy, this is this part here, we've got the hammer, the chisel. The stock is interesting in that this step is for me to put my left foot on. Now you think, well, so what? At the right, by the way, at the same time, my right foot goes into this strap, and the strap is a clamp to hold down the file while it's being cut so it cannot move. At the same time as this knee being here, this allows my arm on which to come up to this level in height, so that when I put my chisel on there like that, everything is falling into a natural position. My right, this of course is a piece of old shoe. I had to wait while I wore my shoe out. It's an old leather shoe, and I had to wait while I wore it out. And this was so you can throw your hammer in it, so you're not looking around where to pick it up. It's exactly where you want it to be, ready to strike. So we are now almost ready, I suppose. My left foot is on there, my knee's up here, my arm is resting on my knee, my hand's holding this. It's interesting, by the way, on this small size of chisel. There were smaller sizes than this, but if you look where my fingers are, it's very close to the top of the chisel. Now if I'm going to hit that like that, and I'm going to catch that many times instead of the chisel head, I'm not going to be at work very much. So how does it miss it? It's due to the shape of the hammer head. So we start by holding the chisel at a bit of an angle. In two planes, it has to be at an angle in this direction, like that, but also at an angle backwards. And what that does is a very clever thing. It makes a groove, so we'll make a groove, like that. And that groove, which I don't suppose you'll be able to see very much, but what that groove does, it's a bit like ploughing in a field. When the farmer ploughs, he makes a groove, a furrow, but it throws up a ridge on one side, which is too small for you to see really with this, but it does do, you take my word for it. And if I hold it at an angle, the ridge is on this side. So the next thing I do is, very briefly, lift the chisel up, pull it back to me, drop it on the file surface and push it back, and that will go up to the ridge I've already formed, if I can find it. It's there. And I do it again. What you will notice, of course, apart from the mist strike, I haven't got my glasses on, so I can't see what I'm doing. So all this is done by feel, and that's the amazing thing, that it's all done by, if you like, the sense of feel. The weight of blow that goes into that chisel determines how deep the furrow is. Try and get it right. And I pull it back, shove it up again. I'm quite sure people who are earning a living with this will do it very, very much quicker than I'm showing you. I don't really know how, but I can go through the motions. This hammer weighs 2 3/4 pounds in weight. They made them up to 8 pounds in weight. Enormous things. Perhaps I'll get one to show you. Click. Ready. For quite small files, this size and smaller, one would use a hammer something like that. That weighs 4 ounces, and there are some even smaller than that. However, for very large files, they have to have a hammer of that size, and that's seriously heavy. That's 8 pound or thereabouts. So imagine lifting that up all day, every day, thousands of times. In 1865, a Dr. Hall did a survey to find out how the industry was going and how many strikes a man had to make a file. And he worked this out in his study, and it makes fascinating reading on the production of files. Eventually, of course, file cutting machines came in roughly after 1860, and more. At first the file cutter said, well, they might be alright, but they're never as good as a hand cut file, and gave various reasons. But eventually, of course, all files eventually became file cut, and only specialised small quantities will be eventually cut by hand. But it's a fascinating study of how an industry came. One thing I should show you is just going back to using the sharpening the chisel, and that is, we found these little, it's a bobbin, this is a cotton bobbin. You can see where it's been the ridge for the cotton to be wound on, and this was along with a lot more things. And it's funny that it's got a sort of a hole through, as cotton bobbins have, and a peculiar shape here. And I thought, well, what the heck's that thing? It came in with, mixed up with other things, so you really no idea what industry it was in. And there's another one there. That's not a cotton bobbin, I don't know what it is. Full of grease and dirt, and the only thing is same sort of thing, one's bigger than the other, etc. And just mulling things over one lunchtime, I thought, I wonder if, and I got a chisel, did that, and I thought, oh, that's handy for this, because if you're actually sharpening your chisel up many times in a day, this sharp piece at the end, this soft metal, is burning over during being cut by the hit by the hammer, and that was very sharp and can cut you. So, and it's much more comfortable to hold it in a holder like that. Oops, Daisy, which way around is it? Like that. And you can then, you've got it in your hand, and you can sharpen it as long as you wish, and it's very comfortable. That other one is for a bigger chisel, but then the same thing entirely. It's a wider stone, I suppose, but in principle that's the same thing. So you keep finding things out about how things used to be done, and it's that's what makes the job interesting. So I hope that this small effort describes something on the ancient craft of file manufacture in Sheffield. I think it was about 1990 the last file manufacturing firm closed down. It was called A.H. Ralston, and Mr. Jack Ralston, who ran it, his father started it, the firm. He eventually said he could buy finished files cheaper from abroad than he could buy the steel in Sheffield, and then he would have to manufacture them. So what was the point? And at that stage he decided to finish, and so he retired. And the file manufacturing in all the UK at that point finished. Files are still manufactured abroad, but as I said right at the beginning, they are being used less and less. In mass manufacturing, the machining techniques are such that they don't need fitting together. If you've got fairly rough work on somebody's welding up parts of a machine that's broken, so the modern blacksmith, he welds it, and if he wishes to smooth it off, he doesn't use a file like he used to, he uses a small electric grinder to do the job. And so all the time new things are coming out, and the old ones have to go, as I will. Thank you.